Let's use the first derivative test to find the relative extrema of the function in example 2 on the interval 0 to 2 pi. First note I want to make is that this is a typo in the notes. This should be 1/2 x minus sine x, otherwise the problem's a little bit boring. To begin, what we want to do is find the critical numbers for f of x. So let's take the derivative. F prime of x is going to be equal to derivative of 1/2 x is 1/2 minus derivative of sine of x is the cosine of x. In terms of the critical numbers, there will be some values for which f prime of x is equal to 0. We set 1/2 minus cosine of x equals to 0. Add cosine of x to both sides, we get 1/2 equals cosine of x. From our knowledge of trigonometry, we know that the cosine in the first quadrant is positive 1/2, and that occurs at the angle pi over 3. The cosine is also positive in quadrant 4, and that angle should be 5 pi over 3. So those would be the two solutions between 0 and 2 pi. This derivative happens to be defined everywhere because cosine has domain all real numbers. So if you're looking for the critical numbers where the cosine would be, where the derivative would be undefined, you wouldn't get any solutions to that part of it. So we just get two critical numbers in this case that are going to fall in our interval. The next thing we want to do is another one of our sine charts. Let's come over here. So we're not looking at it on the entire real number line. We're looking from 0 to 2 pi. And in between there, we have our two critical numbers. The first one is pi over 3. The second one is 5 pi over 3. Those two numbers are going to break this number line up into three regions. We have region 1, region 2, and region 3. And now what we need to do is take a test point and take a look at the sign of the derivative in each of those regions. For example, in region 1, I would like to use a well-defined angle between, let's say, 0 and pi over 3. Good candidates would probably be either pi over 6 or pi over 4. I'll use pi over 4. F prime of pi over 4 is going to be equal to 1/2 minus the cosine of pi over 4. That's equal to 1/2 minus radical 2 over 2. If you want to, you can go ahead and compute the value of this, but we don't really care so much about the value. We just need to know whether it's positive or negative. The square root of 2 is bigger than 1, so that when I subtract that, I'm going to get a negative fraction or negative result overall. So in quadrant 1, f prime is less than 0, which would tell us that the function would be decreasing in region 1. Let's take a look at a test point in region 2. Convenient value to here might be to use x equals to pi. Actually, let's do pi over 2. If we calculate f prime of pi over 2, that's going to be 1/2 minus the cosine of pi over 2. Cosine of pi over 2 is 0, so we get a positive 1/2, which is greater than 0. So in region 2, f prime is greater than 0, which means that the function is increasing. And now we have one more region to check out. Let's take a look at region 3. We need to use a test point between 5 pi over 3 and 2 pi. Maybe I will use, let's say, 7 pi over 4. F prime of 7 pi over 4, this is going to be equal to 1/2 minus the cosine of 7 pi over 4, which is 1/2 minus the cosine of 7 pi over 4 is again square root of 2 over 2. So that will be less than 0, which means that the function is going to be decreasing there. We can now use our first derivative test to kind of highlight what happens at each of the critical numbers. At x equals to pi over 3, we do have a change in the sign of the derivative. It goes from negative to positive, meaning the function changes from decreasing to increasing, and the end result is that's going to create a relative minimum. So at x equals pi over 3, we're going to have a relative min. Remember, the pi over 3, that x value, that's just the location of the relative min. We would actually need to plug that in to get the value of the relative min. Let's go ahead and do that. If x equals pi over 3, then f of pi over 3 would be equal to 1/2 times pi over 3 minus the sine of pi over 3. This is equal to pi over 6 minus the sine of pi over 3 is radical 3 over 2. If you want to, we can approximate that. Let's plug that into the calculator. We'll take it to, let's say, 2 places. On an exam, I would want to see this exact answer. I'm sure that as you're working through the homework and web assignment, they're going to ask you to round to a certain number of places. Just pay close attention to the rounding rules. So that relative minimum is going to be about negative 0.34. So a relative min of negative 3.4 at x equals to pi over 3. Let's see what's happening at our other critical point. At 5 pi over 3, we see that the function is changing again. We have a change in the sign of the derivative. To the right of 5 pi over 3, the derivative was positive, which means that it was increasing. And then to the right of 5 pi over 3, the derivative is negative, which means that it's decreasing. If the graph goes from increasing to decreasing, that's going to create a relative max at 5 pi over 3. So x equals 5 pi over 3 is going to be a relative max. So that's the location. The value of the relative max would be f of 5 pi over 3. This is going to be equal to 1/2 times 5 pi over 3 minus the sine of 5 pi over 3. This is going to be equal to 5 pi over 6 minus the sine of 5 pi over 3 is negative radical 3 over 2. So the exact value is 5 pi over 6 plus the square root of 3 over 2. Which would be approximately 3.48. So we get a relative max of 3.48 at x equals 5 pi over 3.